Hello everyone, welcome to video 4 in the College Algebra series. Today I'll be talking about finding the domain and the range of a function. So let us begin. First is we have what is a domain. So it is a set of all first components of the ordered pair of a function. So as you all know what an ordered pair is, it's written in this form. So it's basically having x comma y inside these parentheses. This is called an ordered pair. So the domain essentially is the set of all first components. That means it's this one, the first component, so that's always the x values. So that is why it's essentially, it's the set of all possible x values. Now next we have what a range is, which is a set of all the second components of the ordered pair of a function. So here in this ordered pair, you see that y is the second component. So that is all the set of all possible y values of a function. To repeat, domain is all the possible x values, and the range is a set of all possible y values of a function. Now let us do an example. Here we are given a set of ordered pairs, and we are asked to find out which is the range and what is the domain of this function here. So as we just followed here what a domain and range are, domain is a set of all possible x values and range is all the y values. So the domain here is all the x values, which is -7, -2, 0, 2, and 3. Let us write them down. So this is a set notation here, is the curly braces. So you have -7, -2, 0, 2, and 3. This is our domain. And the range is all the y values, which are 3, 4, 7, 5, and 8. So you have 3, 4, 7, 5, and 8. So all the x values make the domain, and all the y values the range. And they're always the possible ones of a function. Possible x values and y values. One small trick that I learned how to remember what the range or domain is range starts with an R and has this long line here, this vertical line. And in a Cartesian coordinate, as you know, this is the x-axis and this is the y-axis. So I just remember it as, because this has a vertical line, it corresponds to the vertical line here in the graph, which is the y-axis. So that's how I remember range, to be associating it with all the possible y values. And the other thing is the domain, because y is already taken, it's all the x values. I hope this helps remember what values correspond domain and what values correspond the range. Okay, now that we have done a problem where we were given some ordered pairs and asked to find domain and range, let us do another problem where we're still finding the domain and the range, but now we have some graphs here. So it's better to visualize and see what exactly is happening here. Some things to know before while reading a graph is if you see an arrow mark that goes this way, basically in any direction, if you have an arrow, that means that that line is going towards -infinity or infinity. Depends on which way it is pointing. So if it's going down or to the left, it's usually going to -infinity on one of the axes. And if it's going to the other way, it's probably going to positive infinity in terms of x-axis, but -infinity in terms of y-axis. So we'll know more about what they mean soon. One more thing is if you have an open circle, that means that that point is not included in your function. So that means that if you're writing it as a range, you usually have it as a parenthesis, a open parenthesis or closed parenthesis, depending on which side, if it's the minimum or the maximum, but you always have it as a parenthesis. And if you have a closed circle, that is a filled circle like this, that means that that point is included in our function. So you either get a open square bracket or a closed square bracket. So these are some things to remember is arrow marks, and then you have your parenthesis, and the other thing is your square brackets. And then there are two more symbols here to know. U. It's basically a little more wider than your regular U. You would write it as like A, U, B. That means it's A union B. I will not be covering a lot of sets in this series, but U usually means union, and this means intersection. When talking about graphs, I would mostly assume that we'd be using only this notation, which is U. We will probably use it maybe in one of the next problems here. But for now, just remember that this means union. That means it's a combination of two sets. For example, if you have a number line like this and you have a function that goes, this -4, -2, 2 and 4. Maybe a function only is from here to here and here to here, and you want to write down what your what the domain is. You would say it is -4 to -2, and you would say union, 2 to 4. This basically means that it's from here to here, and it's from here to here. Okay, let us solve these problems now that we know some of the basic notations. The first problem here is you have this a inverted V-shaped graph. Here you see that there's two arrow marks, as I mentioned before. That means that they go towards infinity, right? First thing, let us find what our domain is. The domain is all the x values. So what are all the x values that this graph covers? So it's all the way from -infinity to infinity. Because there are arrow marks on both sides, that means it covers all the values this way and that way. So our domain is -infinity to infinity. So infinity always has this parenthesis here because it's essentially an open circle, because we don't really know what this number is, and this keeps going on and on. So even like as the word says, it's infinity because it keeps going on, and it's a really big number and we don't know what it is. It's usually represented using, not usually, always represented using a parenthesis. Let us now find what our range is. We know that the range is all the possible y values. So here we see that the y values are from 3 in the positive side, and on the negative side, it goes to -infinity. As these arrow marks go more towards both the left and the right, we know that it covers all of the y-axis, which is under our this origin point. So it goes to -infinity. So that would be -infinity to 3 here. Again, 3 is basically a closed circle here because 3 is included in our graph. So we get a square bracket. One thing to always remember when you're writing ranges is you always have the smaller value on the left and the bigger value on the right. So you would write something like 2, 4 or -5, -3, something like that, where your left value, that is your x component here, is always a smaller than your second component here. This is always the larger one compared to the other side. Okay, so that is our domain and range for this function. Now let us solve the second one here. Here you see that, okay, let's first do the domain, and then we'll do the range. This domain again is all the x values, and range is all the y values. So x values again, we see that here there is a closed circle, and here we have an open circle. So here we have an open, and here we have a closed circle. So these are not going to infinity because we do not have arrow marks here, and because we know that the right side is an open circle, that means the right side will have a parenthesis, and the left side, since it's a closed circle here, we will have a square bracket. And the x value that's corresponding to this closed circle is -3. And the x value that's corresponding to the open circle here is 2. So that is our domain. Next, let us talk about the range, which is all the y values. That means it's all of the y values from here to here. This value is included in the graph here. So we get a square bracket on the right side, and this value is also included. So we get a square bracket on the left side. Right? So on the left side, it's -5 is your y value. And on the right side, it is 4 as your y value. So that's our domain, and that is our range. Domain again is all the x values, and the range is all the y values. All right, so now we have solved two problems, where in the first problem we were given ordered pairs, and we were asked to solve what is the domain and the range. And in the second part here, we have two graphs, and we are asked to find the domain and the range, which we were perfectly able to do, and we learned some new notations here, which will definitely be useful throughout this series and will be used multiple times. Okay, now let us find the domain and the range when a function is given, right? So here the function is given as an equation. So here we have f of x equals x squared. As you know, we can call this as y equals x squared. So if you immediately look at this, let me first write this down again. We have the domain is all the x values, and range is here all the y values. Okay, so what would the domain be? Domain is all the x values. So what all values can x possibly take for this function to be a valid function? It would be all the numbers, right? It would be all real numbers. So it would be from -infinity to infinity. So that would be our domain. That is all the values that x can take. So there's no value that x cannot take here in all the real values, right? All the real numbers. And then the range is what are all the y values that this function can take, right? What does this mean? That means that for whatever x it is, if you have x squared, what are all the values that y can take? Which will be all the positive numbers, right? Because x, if x is negative, x squared is positive. If x is positive, x squared is also positive. If x is 0, x squared is 0. So no matter what number it is, it's always a positive number. So x squared, a number squared is always positive, right? So your range would be 0 to infinity. We have a square bracket at 0 because 0 is included. If x is 0, your y is 0 square, which is also 0. So 0 is included in our function. So we have a square bracket, and infinity, because it's infinity, you have a open bracket, right? Parenthesis. Okay, so that is the problem. And next, we have another function where f of x equals square root of x minus 2. So we have f of x equals square root of x minus 2, which is y equals square root of x minus 2. So what are all the values that x can be? Again, domain is the x values, and range is all the y values. So under a square root, for this value to be real, for y to be real, under the square root, any number that's inside the square root should always be a positive number. That means x minus 2 should be greater than or equal to 0. That means when you let us add 2 on both sides, that would give us x is greater than or equal to 2. Whatever value x takes, if it is greater than or equal to 2, only then will this function here be a valid function, right? So the domain would be x greater than or equal to 2. You can write this in this form where you have 2 comma infinity. Because this is greater than equal to, that means 2 is included in our x values. We would have a square bracket, and the infinity will have a parenthesis. Now let us find the range. So a square root is always positive numbers. So that means that y only takes positive values. So that would be 0 to infinity again. 0 is again included. For example, if you think x was 2, 2 minus 2 is 0, square root of 0 is 0 again. So 0 is included. So it would give us a square bracket here and an open bracket here, open parenthesis. You must be wondering, because in all the past videos, whenever I said square root of 9, we always took this as plus or minus 3, things like that, where we always take the positive and the negative values of square root. This is usually because when we have y squared equals x, then y is plus or minus square root of x. That's where this plus or minus comes. It's not from the square root itself, but from the y, like when we are square rooting on both sides, on left and right, that is when you get the plus and minus. But here in the function, we are already given that y is square root of x minus 2. That means that we are only considering the positive values. That is why we are only taking the positive values here. For example, we were given y squared equals x. Let me make some space here. For example, we were given y squared equals x. Then this would not be a function, because that means that for one x value, there are two y values, right? So y equals x squared would look something like this. And if you do the vertical line test, it passes through 2 points. So y squared equals x is essentially not a valid function. It would be a valid function only if we have y equals square root x or y equals negative square root x. Then we have a valid function, because y equals square root of x would look like this, and y equals negative square root x would look like this. So that is why we have only the positive values here, because this function here is only talking about the positive square root of x minus 2. I hope that made some sense at least. I think doing more problems and trying to understand the positive and negative numbers and how graphs work will make this concept a little bit more stronger in our heads. Okay, let us do another problem here. Here we have describe the domain for the functions, and we are given 2 functions here. Let us do the first one. Domain is again all the x values, right? So we are only calculating the possible x values that this function can take. So the first one here, we have y equals 7 by x minus 6. So one thing we all know is when we have a fraction, a by b, this is valid only when b is not equal to 0, right? So a denominator should not be equal to 0. If the denominator is 0, you would have, if a by b and b equals 0, then a by b is undefined. So essentially, for this to be valid, this value here, which is x minus 6, should not be equal to 0. That means adding 6 on both sides, x should not be equal to 6. So x can be any number, definitely not 6 for this to be a valid function. So how would you write this as a range of numbers? So that would be that you have any number from negative infinity to 6, but you have an open parenthesis here, and then you say union 6 to infinity, where again 6 is not included. Okay, I made a mistake here. This is supposed to be parenthesis as well. So what does this parenthesis mean again? That means that that number is not included, right? So it's minus infinity to all the numbers until 6. So it can be 5.9999999, and it goes on, but it never goes to 6. And the same thing here, it would be 6 to infinity, where 6 is not included. So it could be 6.00001 to infinity. And then we have parenthesis on all sides because infinities always have parenthesis, and here 6 is not included, so that's why we have parenthesis on 6. You can write this in another way, where you can say that it's from minus infinity to infinity without the set of 6. So this also means that it's all of the number line. Let us say this is 6, this is 0, and I don't know, 100 or something. And then it goes to infinity, and this goes to infinity. So what this means is all of the number line except for this. So you have a open circle here and everything else. This notation here means that you have negative infinity to 6, and then from 6 to infinity. So except for 6, it's all the other values. Okay, so that is the end of the first bit here. In the second bit here, we have y equals square root of 7 minus 5x. As we know, under the square root, for this to be a real value, we should have 7 minus 5x always greater than or equal to 0. That means negative 5x is greater than or equal to negative 7, subtracting 7 on both sides. And now we want to divide both sides by negative 5. And one thing to take care is, because we are multiplying essentially both sides by a negative sign, or dividing by negative sign, you could take it as any way. The signs change, the signs flip. So when you're dividing here by a negative number, this would become 5x, x less than or equal to 7 by 5. Again, if you're multiplying an inequality with a negative 1 on both sides, then your inequality sign flips. So if you have a greater than, it becomes less than. If it's less than, it becomes greater than. Same thing with less than equal to and greater than equal to. Same thing again. So essentially here you have x is less than or equal to 7 by 5. So our domain would be negative infinity to 7 by 5. Where 7 by 5 is included because we have this, it's negative, less than or equal to. So because we have the equal to symbol as well here, we have a square bracket. That is our domain of this function. Okay, again, these are the same graphs which one we found the domain and range for. And let us do some more analysis here. So it's for the first part, the first graph here, it's asking what is f of 1. So what is f of 1? That means it's asking for the y value. So that's 2. So you just say y is 2. This find x such that f of x equals 4. So f of x is 4. That means f of x is 4. That is y is 4. It's asking for what is the value of x. If there is an x, find that x. We see that there's no x such that f of x is 4. So you just say it's not possible. Next, it's the x-intercepts. So x-intercepts are the points at which the graph meets the x-axis. So here there's 2 points, here and here. So that is -1, 0 and 5, 0 are the 2 ordered pairs, which are the x-intercepts of our function. That is where the graph meets the x-axis. And what is the y-intercept? Here we have the y-intercept. That's where the graph meets the y-axis, which is at 0, 1. So here we have this as our y-axis, and the y-intercept, and these two are our x-intercepts. There is a repeat here. Find x such that f of x equals -5. So f of x again is -5 here. That is y is -5. If you draw a vertical line, you see that it never really intersects with our graph. That means that there is no oh, wait, sorry, I got confused. It says f of x is -5. That means y is -5. I was thinking x was -5. Okay, so y is -5. That means if you draw a horizontal line here, we see that it intersects here with the graph, and you see that this is a closed circle. That means that number is included in our graph. So what is the x value such that f of x is -5? So that is -3. So here x equals -3. Now next question is, what is f of 2? So f of 2 here means your function at 2. So y is 2. What is the x value? I would assume it's 1.5 around. So I would just say 1.5. So if we had a question that says find x such that, or find y such that f of x equals 2, you would say this is not possible because here we have an open circle. Open circle means that there's no y value that exists at that x value there for this function. This is not possible, or there's no value, it does not exist. You could also say D and E, which means does not exist. X-intercepts here are again the ordered pairs, or the locations where the graph meets the x-axis. Here we have only one x-intercept, which is -2, 0, because here, even though it looks like the graph is meeting your x-axis, it's an open circle. So you have only one x-intercept here. The second one is the y-intercept, that is where the graph meets the y-axis. So that would be 0, 4. So that is the end of this example here. And the last part here is just a picture of some common functions and their graphs. It is important to sort of have these in our mind because most of the functions that you would see in this class or pre-calculus or some of the basic math courses, or I think even throughout your math career, most of the graphs roots, the root values of your graphs are usually one of these graphs. So it's really important to just have an idea to know what these are instead of plotting them every single time. So it's just faster, and it's just good practice to know these basic graphs. This is a constant, and here we have y equals x, and this is the absolute value. This is the square root. This is the quadratic function, the cubic function, the reciprocal function, which is 1 over x. And you have the greatest integer function, which is represented this way. Yeah, or you can also represent it this way. That is the end of this video here. And I hope you learned something from this video. And if you know anybody who would think would benefit from this, please do feel free to share it. And I will see you on the next one.